Let's solve this limit here. So first of all, as you can see here, this limit here has a power of x here. So it's not easy to solve. One way to do that is we can apply the property of natural log so that we can move the x to the front. To do that, I will have to first let y equals to this limit here. Now, we will take the log of both sides. So this side will be ln of y equals to ln of this. And of course, we have to take the limit out of the natural log here. Now we can move the exponent of x here to the front. Okay, now, so what do we do? Now we're taking a limit as x approach infinity here, right? So if we put in infinity here, it may not really get you to anything. But what we can do is, this x here, we can rewrite this as dividing by 1 over x. Because dividing by 1 over x is the same as multiplying by x here. So we can rewrite this as here, ln of 1 plus 3 over x plus 5 over x squared divided by 1 over x. Like this. This is the same as this. Why do I do this? Because now I can put infinity into x here, right? To see if I can get something like 0 over 0 or infinity over infinity, because I want to see if I can apply the L'Hopital's rule. Okay, so let's do it here. If we put it in here like this, so ln of 1 plus 3 over infinity plus 5 over infinity square, right? Divided by 1 over infinity. Now, over here, as you can see here, right? This term would become really, really close to 0, so it's going to be 0. This term, same thing, 0, so at the end, you have ln of 1 here. ln of 1 divided by 1 over infinity is close to 0, right? And that would be equal to, now, ln of 1 is 0, so that is 0 over 0. Okay, so we have the indeterminate form here. So we can apply the L'Hopital's rule here. And I don't need this anymore, so I will erase this. Okay, now, let's do this. ln of y is equal to limit as x approach infinity, derivative of the numerator over the derivative of the denominator. Okay, here. Let's do it on this side here. The derivative of this. Or let's just do it here. Okay, so derivative of ln of 1 plus 3 over x plus 5 over x squared. I can rewrite this as derivative of ln of 1 plus 3 times x to the power of negative 1 plus 5 times x to the power of negative 2. Right? Now that would be easier to do. Okay, so first of all, you see another function inside another function here. So we can use the chain rule. Now let g equals to this function here, ln of 1 plus 3x to the power of negative 1 plus 5x to the power of negative 2. Okay, let me let u equals to the function here. So 1 plus 3x to the power of negative 1 plus 5x to the power of negative 2. Then g is equal to ln of u. Right? Because this is u now. Now, first of all, let's take the derivative of u with respect to x here. So du over dx. So that is 0, right? This one will become negative 3 times x to the power of negative 2, right? And then this one will become plus, okay, let's do it slowly. 5x minus 3. Okay, so that would be equal to, that would become minus 10x to the power of negative 3. Okay. Now, next, take the derivative of g with respect to u. So that would be dg over du, right? Derivative of ln of u is just 1 over u. And u is equal to this function here. So we can rewrite this as 1 over 1 plus 3x to the power of minus 1 plus 5x to the power of minus 2. Now, to find the derivative of dg over dx, which is what we are looking for, right? That is dg over du times du over dx, right? Du and du cancel out, all we have left is just dg over dx. What's dg over du? It's this, right? So it's 1 over this. 1 plus 3x to the power of negative 1 plus 5x to the power of negative 2 times, what's du over dx? This. So times this. Okay, now let's write this. So this is just equal to minus 3 over x squared minus 10 over x cubed, all divided by this is 1 plus 3 over x plus 5 over x squared. Okay, so this is the derivative of, here, ln of 1 plus 3 over x plus 5 over x squared. Now, what's the derivative of 1 over x? Derivative of 1 over x, that's just equal to negative 1 over x squared. Okay, now let's put this together. Now let's take this and then right here. ln y is equal to Now, derivative of the top is equal to this. So we can write this as limit as x approach infinity. The top will become minus 3 over x squared minus 10 over x cubed, or divide by 1 plus 3 over x plus 5 over x squared. Now divide by negative 1 over x squared. Okay, so this part here, right, I should write it in the middle. So ln of y is equal to limit as x approach infinity. Okay, now over here we can see that we can factor out the negative 1 over x squared here. Why do I do this? Because I want to cancel out with this one here. Now that's equal to negative 1 over x squared times, now this will become 3 plus 10 over x, right? Divide by this here. Now this whole thing divide by negative 1 over x squared. Okay, now this and this cancel out. What I have left is ln of y is equal to limit as x approach infinity 3 plus 10 over x all over this 1 plus 3 over x plus 5 over x squared, right? Now, can we just put infinity into x here? I think we can now, okay? So ln of y is equal to 3 plus 10 over infinity, right? Divide by 1 plus 3 over infinity plus 5 over infinity squared, right? Now, ln of y is equal to now 3 plus 10 over infinity is a really small number close to 0, so that's approaching 0, right? Divide by 1 plus 3 over infinity close to 0 plus 5 over infinity squared close to 0. Then ln of y is equal to 3 over 1. That's equal to 3. Okay, now ln of y is equal to 3. But we want to find y, right? To do that, we just have to take the exponential of both sides. We have e to the ln of y equal to e to the 3. Now, e to the ln of y is just equal to y. So y is equal to e to the 3. But what is y? Y is what we said at the beginning, equal to the original limit, right? Okay, so we found out that the original limit is equal to e to the 3. Okay, hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.